Good day. Welcome to One-on-One Maths Private Tutors. Today we are looking at this chapter in O-Level Cambridge Mathematics, sequences. What is a sequence? A sequence is a particular order in which related things follow each other. So in mathematics, we are dealing with numbers. So it's a particular order in which related numbers follow each other. We have this sequence here. So we are looking at number patterns. What is happening when we go from one number to another? We have a set of numbers and we want to find how they are related. How do we come from one number to the next? So we have this number pattern. Here is a number pattern. So we are saying position of the number and value. So putting these in a table, we will have the first position is number 6. On the second position is number 11. On the third position is number 16. On the fourth position is number 21. On the fifth position is number 26. On the seventh position is number 31. What operation are we doing to get from this number to this number, or from this number to that number, or from that number to that number? Operations we have are addition, multiplication, division, and subtraction. So we test all this. Are we adding? Are we multiplying? Are we dividing? Are we subtracting to get to the next number? So let's start. If we say number on position 2 minus number on position 1, we can see these are increasing. So it should be a multiplication or addition. If the numbers are increasing, then we are multiplying or adding by a certain number. It's most likely that we are multiplying or adding a certain number. So we can say 11 minus 6, then we get 5. 16 minus 11, then we get 5. 21 minus 16, again we get 5. 26 minus 21, again we get 5. 31 minus 26, again we get 5. So each time we are adding 5 to get the next value. To get the second value, we are adding 5 to the first value. To get the third value, we are adding 5 to the second value. So we can see how the sequence is going, the order in which these related numbers are following each other is adding 5. So we can even get the next number by adding 5. So if we're asked for, let's say, the 10th number, we add 5 to 31 to get the 8th number. And when we find that number, we add 5 again to get the 9th number. And to get the 10th number, we add 5 again. Now, here is another pattern. We have 1, 2, 4, 8, 16, 32. This is the value. Okay, we have the first number as 1, the second number as 2, the third number as 4, the fourth number as 8, the fifth number as 16, the seventh number as 32. So what are we doing to the first value to get the second value? What are we doing to the second value to get the third value? We can see there is an increase. So we might be interested in finding the difference. If the difference is the same, then we can say we are adding a constant value. So 2 minus 1 is 1. 4 minus 2 is 2. 8 minus 4 is 4. So we can see we are not adding the same value every time we move from position to position. Let's try to divide this so that we can see if we are multiplying this to get that. Okay, so we use division. 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. 32 divided by 16 is 2. So what are we doing to this to get that? So the thing is we are multiplying now. 1 times 2, we get 2, then we put 2 there. 2 times 2, we get 4. We put 4 here. Then 4 times 2, we get 8. 8 times 2, we get 16. So each time we are multiplying. But how did we find that out? We first divided the second by the first, divided the third number by the second, so that we can get a factor that we are using, and we see it's the same throughout. From number to number, there is a factor of 2. So we are multiplying by 2 each time to get the next value. Let's look at these questions. Position value. Position always starts from 1, 2, 3, 4 going up. And the value is what we have there in our sequence. So it's 1, 4, 7, 10, 13, 16. We are seeing these numbers increasing in the sequence. So it's likely an addition or a multiplication. Let's test addition. We take this number and subtract the previous one. 4 minus 1, 3. 7 minus 4, 3. 10 minus 7, we get 3. 13 minus 10, again we get 3. 16 minus 13, we get 3. So each time we are adding 3 to a number to get the next. 1 plus 3 is equal to 4. 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13. 13 plus 3 is 16. So find the term-to-term rule for each of the sequences. So we are saying for this one it's plus 3. We are adding 3 every time. Now let's look at B. The first term is 63. Position 1 is 63. Position 2 is 56. Position 3 is 49. Position 4 is 42. Position 5 is 35. Position 6 is 28. So either we are subtracting or dividing a certain number, because we can see there is decrease here. Okay, we are starting at 63, ending up at 28. We are going down the number line. So let's test for subtraction. We take this one, subtract that one. 63 minus 56, that's 7. 56 minus 49, again we get 7. 49 minus 42, we get 7. 42 minus 35, we get 7. 35 minus 28, we get 7. So there's a constant number here that is being subtracted. We subtract 7. So the term-to-term rule for this sequence is minus 7. Okay, now we have this table for C. Position 1, there's 1 million. Position 2, there's 100,000. Position 3, there's 10,000. Position 4 is 1,000, and 5 is 100. So what are we doing to this term to get that term? That is the rule-to-rule sequence. And what are we doing to this term to get that term? It's either a subtraction, because the numbers are decreasing every time, or a division. So we can start by 1 million minus 100,000. We are testing for subtraction. We'll get 900,000. 100,000 minus 10,000, we are getting 90,000. Already the rule is not applying because these two are different. So we try division. 1 million divided by 100,000 will give us 10. 100,000 divided by 10,000 will also give us 10. 10,000 divided by 1,000 will give us 10. 1,000 divided by 100 will also give us 10. So since we are going down the number line, we are dividing by 10. So each time it's a division by 10. 1 million divided by 10 is 100,000. 100,000 divided by 10 is 10,000. 10,000 divided by 10 is 1,000, and 1,000 divided by 10 is 100. So that's the term-to-term rule. We are dividing by 10 each time. So in some sequences, we may be given a list with some missing numbers. So the idea is to find the rule, then fill in the missing numbers. So what is happening here? So we have these two numbers that are in sequence. We can get the rule from these two. 10 to 17. We could be adding 7. 10 plus 7, we get 17. Is it the same here? 38 plus 7, what do we get? 45. So we are adding 7. So we have 10, 17, then we say 17 plus 7, then we have 24. Then 24 plus 7, then we have 31. If we add 7 to 31, we get 38. So this is working out. And then 45, we know this, we are adding 7. So it's adding 7 all the time. Adding 7, adding 7. So our numbers here that are missing are 24 and 31. Let's look at B. We have 35, we are going down. Okay, let's try 23 and 17. 23 minus 17, we're getting 6. So let's try subtracting 6 all the time. So we can say 35 minus 6, 29. So if we put 29 here, 29 minus 6, we get 23. This is working out so far. 17 minus 6, we get 11. Then if we put 11 here, let's say 11 minus 6. 11 minus 6 will give us 5. So these are the numbers. Our rule here is minus 6. Okay, let's look at C now. Let's look at the difference between these two numbers. 27 minus 23 will give us 4. 31 minus 27 will again give us 4. From 23, we are adding 4 to get 27. From 27, we are adding 4 to get 31. So what do? We are saying from this number, we are adding 4. So to go back from 23 to this number we are looking for, we subtract 4. So it's 23 minus 4, then we get 19. Is it the same? If we say 15 plus 4, get 19. Now to go back there, 15, the previous number, we must, since we are adding 4 from here to there, we must subtract if we are going in reverse. So we can say 15 minus 4, then we get 11. So this first number is 11. So the sequence here we can see is plus 4 if we are moving from term to term in the positive direction. Now, sequences have names. So when you are adding or subtracting, it is called a linear sequence. Okay. When we add or subtract a constant value to a term to get the next term, we have a linear sequence. What do we mean? When we are at 2, we add 3 to get 5. And when we are at 5, we add 3 to get 8. This is what we call a linear sequence. Each time we are adding a constant value, in this case 3, to get the next term. This is what we call a linear sequence. Likewise, when we are subtracting, 11 minus 2 will give us 9. 9 minus 2 will give the next term 7. 7 minus 2 will give the next term 5. And 5 minus 2 will give the next term 3, and so forth. This is called a linear sequence if we're adding or subtracting. So to test if it is a linear term, you should find the difference between successive terms. And if the difference is the same, then it's a linear sequence. Thank you.